Hi guys, and welcome to Contextual Electronics. My name is Chris Gamble, and today is an introduction to KiCad in an even simpler method than getting to Blinky. Getting to Blinky was a 10-part process to get you acquainted with KiCad, all the pieces of KiCad, including footprints and schematics and everything like that. But it was even a little bit too busy for some people, right? It took a little bit of time, and at the end you still had to, do quite a bit of things. This is meant to be an even simpler introduction. Now, a lot of people that I talk to about contextual electronics, they're in the software world, they're interested in doing more with hardware, they've got some development boards, and they're ready to build their own thing. That's kind of who I'm interested in. Obviously, I'm interested in talking to everybody, but it seems like that's kind of the biggest crowd. So today, we're going to start a new project called On You Crazy KiCad. It's going to be a very, very simple introduction, and it's going to be using a popular platform called Raspberry Pi. And if you've never seen it, Raspberry Pi is a development board. It's about 30, 40 bucks. It's basically a small Linux single board computer, and from here a lot of people want to start building things onto the headers up here, and so that's exactly what we're going to do. We're going to build something onto the leftmost 10 pins of a Raspberry Pi, but it's going to be a very simple thing. There's going to be two LEDs, one of which that goes on whenever you plug it in, so it's powered, and the other one that turns on when you turn it on. From here, right, so you'll make a small board that you can practice SMT soldering on, which is not as scary as you think it is. You can also practice, doing some Gpio output. From there, then you can use this as kind of a launching pad for building your next thing. And so we've got some ideas of building small other boards from a Raspberry Pi interface again, but need to do this step first. So let's get through a very, very simple build, and then from there, you can build, well, the sky's the limit. So first off, let's take a look at the header of what we're looking at here and why we chose the leftmost 10 pins. We wanted to have power and ground, and obviously this has a bunch of it. And so, keying it to one side of the connector versus the other makes it really nice and easy, right? So this is the side with power. That solved that. We also wanted some Gpio, so we're going to do the leftmost 10 pins because now we also have 5 Gpios, 2 of which are I2C, which is interesting, and 2 of which are serial. So, if you want to reuse this in the future, that's going to be another interesting thing from there. So what we're going to do is pull these 10 pins into a schematic, put the whole thing, and then what we'll do is we'll have on the header here, rather, what we're going to do is we're going to use female pins. These are called male pins here. These gold pins that you can plug stuff onto. We're going to have, we'll have a 10-pin part number that you'll be able to plug right onto there, and that's another key thing. So let's take a look over at KiCad and get started. So, there we go, sorry. So we're in KiCad. There's an install, pretty easy install. I'm on Windows, but this is also available for Linux and Mac. So what we're going to do is start a brand new project. I'm going to call it Shine. Great. And from here, I'm going to open up the EE schema, which is the schematic editor. And the first thing I'm going to do is go in and, first thing I'm going to show you is if you hit the question mark key, if you hit question mark at any time, it pulls up a hotkey list. And this is a very important and useful thing to learn over time as you get more and more into KiCad. But the first thing we're going to do is start dropping some components, including LEDs. So I go to Add Component, I click, I type in LED, and I'm going to drop this here. I'm going to drop 2 of them. I'm going to hit R to rotate. I'm going to hit C to copy. And then I'm going to go back into that same menu, which I can also do with A. And then I'm going to go type in R for resistor. I guess I can spell that right, huh? So there's a bunch of them here, but what I usually just do is R, because that's actually the symbol. And I'm going to drop 2 of these here. Again, we're not going to talk much about the theory. We're just going to talk about putting these components in here. I'm using my mouse wheel to scroll in and out, and there is a bunch of stuff around that. Mouse over and hit C to copy. You can also right-click, select the component, and then say Copy Component. It is definitely an unconventional interface here, so that's a common complaint that I hear. I'm going to hit the green wire over here. This is a wire. I'm going to connect these 2 things together. Okay, and then at the top, I'm going to connect them. They're going to be at this using the same ground at the bottom, but different connections at the top, right? And so what I'm going to do is connect these at the bottom together. Okay, and now what I'm going to do is split my screen so that I can, view this stuff together. Okay, so now we're going to pull in a 10-pin connector. So I'm going to once again hit A. That loads up this thing. I'm going to type CONN to start searching, and I'm going to go for a 2x5. That's what I'm really looking for here. A 2x5 connector, right? And so what we're going to do is match up the pin numbers with the pin numbers we have here. So this is going to be 3.3 volts, right? And then, so what we're going to do is we're going to actually just label these things. We're going to label them with text. Now we could also label them with with actual labels like that connect the nets together, but we're not actually going to do that here. So we're going to say 3v3 and then Gpio2. Let's see if these actually space out well. Gpio3 and Gpio4 and ground. Okay, let's see how that looks. Not too bad. And then over here, I'm going to do another one. So this is going to be 5V, 5V, GND for ground, GPIO 14, and GPIO 15. Great. So we're just going to put these labels next to it, and then we're going to actually connect things directly together. Now this is different than I normally say, but because of for simplicity's sake, we're going to do this a little bit different. I'm going to hit W to start a wire again. So W to start a wire, click, oops, Control Z undoes, click to start, and then I'm going to connect into, so the bottom is going to connect to the ground, right? So we're going to connect to pin 9. The top, we're going to connect to two different things, right? So the left side is just going to be the power indicator. So we're going to hook that into the power rail here. So basically whenever you plug this thing in, the left LED will go on. And then this one's going to go into GPIO2, so that whenever you turn on GPIO2, whenever GPIO2 goes high, then this LED will go on. Okay, so now we're going to mouse over, hit V. That's going to change the value. We can basically assign a value here. We're going to say it's a 200 ohm resistor. Same thing here, 200 ohm resistor. And then, again, tracking the values here, that's another topic for another day. LED, we're not actually going to put the LED that we're going to buy in here. We can do that in a future video. But now what we're going to do is add no connects for these other ones, right? Just to show that we're not connecting these other pins. Just click on each pin, and now when we do a check, it'll say, oh, fine, those aren't connected, no big deal, because we actually indicated that they should be like that. Now what we're going to do is called annotate. So you see that's J question mark, and these are LED question mark, or D question mark, and R question mark. We want to actually give these numbers, and it actually does an auto assignment of numbers. It's called annotation. It's this button up here. Hit annotate. We're going to say OK. And now you see that they all have numbers, R1, R2, D1, D2. Great. OK, from here, we're going to go in and do a ERC. This is just checking that everything's connected. So we're going to hit run, and you see that there are no problems here. Now if we go and disconnect, let's see. So if we disconnect this wire, mouse over and hit delete, right? Now if we do it again, we should see an error. You see now we have 2 pin unconnected errors. It shows you when they're not connected. So we'll connect those back together. W to start wire, hit the check, and we're good. Okay, great. So now we have a connector, we have 2 LEDs, and we're ready to go. Okay, so we're going to hit save. We're going to generate a netlist. This is basically the translation layer between the schematic, which is what we're looking at, and the layout, which is the physical thing that we're going to go build. We're going to hit generate. It just saves the netlist. You can go take a look at that if you want to. And then from here, what we need to do is we're going to do something called CVPCB. Now, I'm going to take a quick break here and talk to the camera. This seems a little bit complicated so far, but we're doing pretty well, right? So what we're doing is we created a schematic notation, which is kind of a symbolic representation of what we want to have in the schematic. Now what we need to do is connect that symbolic representation to the actual real world, whatever we're going to solder to when we have a board, right? And so what this does is it connects the schematic symbols to the layout footprints. And so that's the level that we're doing now. Okay, so into CVPCB. From here, it's loading up the libraries, and sometimes it throws some weird errors here. If you do have any errors at any time, you can see it's kind of loading them up for the first time for me. If you have errors at any time, you can go over to a site called forum.kaicad.info, and there's a bunch of helpful people over there. Okay, so what we're going to do here is we have D1, D2, J1, R1, R2, right? So what we want to do is we want to go and search through the libraries that we have connected here. And like I said, I wanted to make sure that we have libraries that are all default for us. So the first thing I'm going to do is go to LEDs. It might be under diodes actually. Let's see. Oh, LEDs. There we go. Okay, so now we have all the LEDs here. What we're going to do, we're going to be using 1206 LEDs, right? There's a bunch of default ones that you can use. Double click to add it. You can see it kind of added it in there. I guess you can move this over a little bit. So you can see it added it, it assigned it to D1, right? So now we actually are linking these things together. Same thing here. We're going to skip that one for a second. We're going to go to resistors now, which is further down. So resistors, SMD, we are doing SMD. So we're going to do 1206 hand soldering because we are going to be hand soldering as well. So now we've assigned those. And now this one we're going to go to, I believe it's pin heading? Pin headers, yes. A weird one. So we're going to go pin headers, and we're going to go to pin headers straight. You see these are all angled. And if you want to preview what they look like, you can actually do that here. So it actually shows what the footprint preview looks like. So we're going to go down to pin headers straight, and we're going to do 2 by 5 rather. That's what we really want here. There we go, 2 by 05. And then we also want to get the pitch right. So we got 2 by 05, 2.54, and we want through a hole, not SMD for this one. So there we go. Take a look at what that looks like. That's exactly what we want. So this is going to be pin 1 will be actually hooked into pin 1 here, right? So this would be rotated to the left, and we'll match this, how this looks here on our layout, which is what we're about to go into. Okay, so we can close this. We can minimize this. Okay, we're going to hit save. So we've saved the association between the header, sorry, the schematic symbol and the footprint. We're going to go back over to the layout here. Sorry, the schematic here. We're going to generate a netlist again. Now, this is a tricky part for most people because they're like, well, why do I have to regenerate it? It's because now what we've done is we've assigned all these footprints to these components. If I mouse over and hit E, you can see we now assign the footprint here, so we need to kind of update that information. Like I said, the netlist is the layer between the two, right? So between schematic and layout, you need to have some kind of translation layer, and that is the netlist. So let's go back to our product launcher. We're going to do that, and we're going to open up the PCB new, which is the circuit board editor. This is going to be the first time I've opened this up. So you see there's nothing here, and it might be kind of hard to see, but there is a red outline. Now this is just a drawing sheet. I'm not sure why they do this, but it's just a sheet that they have on there. It really doesn't impact you too much. So I wouldn't worry about that. But what we want to do is we want to go and read the netlist, and it should, because we're in the same project, it's just going to go and read the netlist that we have there. So we see checking footprints, we have all our errors and warnings and whatever here. And what we should have is a pile of footprints here. Great. So I'm going to go to footprint mode, right? I'm going to right click, and then I'm going to say we're going to say global spread in place. Now this is the easy way to do it. We could also go and grab those and move those out ourselves, but as you have more and more footprints, you want to do this automatically. So we're going to spread out all footprints. Hit yes, and now that's spread it out for us. Okay, great. Now I'm going to move this over like this and pull our thing back up here. And like I said, I'm going to remind you what this looks like. So what we're going to do is we're going to be building a little board that comes off of these headers, right? So the 10 here. So what we're going to do is we're going to put the stuff up above and kind of out to the left here, right? So this is where the header will plug in, and then the board will be up above it. So it's going to be a small board. It doesn't have to be big, right? But what we're going to do is we're going to rotate this stuff so that it kind of looks like that, right? So I'm going to mouse over, hit M to move. These hotkeys are the same here, but if you need to, hit question mark. This should show you the hotkey list and how it's different for. This is honestly how I learned KiCad, is through the hotkey list. So that is a very, very useful thing. Okay, so we're going to mouse over, hit M to move. We're going to rotate it. And from here now, what we're going to do is we're going to go and draw an outline around here. Now, I'm going to draw a board outline, and we're going to draw one that's about 1 inch by 1 inch. You can make it as big or as small as you want to. I just think it's nice and easy to make one that's 1 inch by 1 inch. So what I'm going to do is I'm going to turn off footprint mode, which was on for moving footprints. I'm going to draw a line, and now what I'm going to do is select the layer, which is the edge cuts layer. This is basically defining the outline of the board. Now, you also need to view down here. Hopefully it's not cut off, but down here it's tracking where the mouse is at any given time. There's the absolute position, and then what's called dx/dy. So this is tracking a relative position, but it's relative to a point that I determine. So if I hit the space bar, it's going to reset. You see now it's at 0, and I can move everything around. What I'm also going to do is I'm going to right click. I'm going to change the grid size. You can see it's currently at 2 mils, which is 0.002 inches. I'm going to make this something much bigger. I'm going to do 25 mils. You see, you can actually see the dots now. You can see kind of it's like this quantized as my mouse moves around. So now it's doing 0.025 inches between each spot, and that's more than enough. So what I'm going to do is draw I'm going to draw an outline around there. So in order to start drawing, just click to start because I've already got this selected. I'm on the right layer, the edge cuts layer. I'm going to hit spacebar to reset my thing. You can see the DXDY in the bottom corner. Click to start. I'm going to go up by 1 inch. There we go. So I'm at minus 100, 1.000. I'm going to go over by 1. Now I'm looking at DX, minus 0.1000. This should go back down to 0 now. There we go. And then I can zoom in and I'll finish this off. Okay, so now that is a 1 square inch board that we're going to be used as our outline, right? Now we're going to move this connector so that this is in the bottom right corner, because remember we said we're going to have all the stuff up and off to the left, right? Now what we're going to do is move some of this stuff around so that it makes sense. So what we're going to do is move, let's see, so let's go back to our schematic real quick. So we're going to D1, we're going to follow our convention that we've set up here as well. So D1 will be on the left, and that'll always be on as soon as this thing's plugged in. Oops. I'm going to save that just in case I hit close by accident again. So D1 will be on the left. And then R1 will be below it. Move this. I'm going to hit R to rotate. And then we're going to move D2 here. And R2. Oops, and I got those upside down. Now you see these lines here. These are actually those are called rat's nests. And what they are is it's showing you a preview of what you will need to be connecting here, right? And so when I start drawing, I'm going to try and follow these rat's nest lines so that I can make this connection happen. Let's see how that works here. So yeah, that looks right there. Okay, so this is to draw a trace. I'm going to go back to my copper. Now this is the top copper layer. Right, so everything's being done on the top of the board right now, and that's how we'll keep that going. So what I'm going to do is connect from here. I'm going to click trace to start, add tracks rather, and then you can see my default track is at 9.84 mils. That's fine. We're not going to do any vias. So we're going to go here. We're going to connect the bottom of R1 to bottom of R2. You see that it's highlighting these nets as we try and connect them here, right? And what I'm going to do is try and go around here. Now, each time I click, I'm basically creating a new edge. And you see also, if I zoom in, you see there's an outline around the trace. That's what's called the that is from the design rules that we'll set up and look at in a second here. Okay, so we've connected that one. Now we're going to go and try and connect these other ones. I can see we might already have a problem, but we'll give that a shot. Can we do that? I think we can. All right, I'm going to delete one of these traces real quick. Mouse over, hit delete, and that's fine. And then I'm going to move these components over a little bit. Okay, and what I'm going to do is go and draw. I'm actually going to move this header over a little bit as well. So I'm going to move the whole header by mouse over, hit M. You can see it disconnected that line, but now I can hit X to go and start drawing that trace again. You see, I just finished out that trace, and now it's reconnected. And now I'm going to go and connect this up. Now you don't have to worry about anything that's red is basically on the same layer. Everything else is on different layers. Now there's lots of different layers, and we can talk about that in a second. But the main thing to know is that we're trying to basically get everything connected on the copper layer right now. Okay. Now if I zoom out, zoom back in, oh, these are not connected. You can also see down here, it says 3 unconnected nodes. So you need to connect those, and there's these 2 as well. Okay, so we've connected all of our stuff up. We see have 0 unconnected. Now what I'm going to do is add some text here. You can add whatever you'd like, but I'm just going to say shine on. And then I'm going to put this on the silkscreen layer, which is, it's like a screen printing basically that goes on top of the board. Right, so now all this stuff, you can see there's other things that are in screen printing as well. We have the resistor, R2 is listed there, R1 is listed there. What we're going to do is we're going to actually turn off what's called the, these are called the values. We're going to turn that off when we, actually we're going to turn this off now. So I'm going to mouse over, hit E, I'm going to make them invisible. There we go. Invisible, especially for this one. All right, so we can take a look. We have two LEDs that will turn on. One turns on when we flip on Gpio 2. The other one will be on whenever. And we could label them as much as well, right? We could say something like, I want to do another one here. We could say this one is just power. Inside silk, and this one will be, oops, GPI 2. This will be on front side silk. Now it's defaulting to the copper layer because I have copper layer selected up here still. If we want to change the size of this thing, we can do that by changing it here, right? We'd say the width is now 0.08 and the height 0.08. We can change the thickness a little bit to 0.015. There we go. Okay, so now we have this. We can save this. Let's go and take a look at this in 3D, which is kind of a fun feature. So we already have a lot of these models in here. Now this is showing as male pins on here, but just as easily we can plug in female pins, which we'll actually do, and we'll actually do that on the bottom side. But this is actually what it's going to look like, right? So if you hit the middle key, you can drag it around. If you click with the left mouse, you can click around. And this is a nice little 3D view here. We can actually do realistic mode as well. What's it called? Realistic mode. Oh, that was realistic mode, sorry. That's as realistic as it gets. You can see that we have SMD LEDs on there. We have some resistors, and we have male pin headers, but what we'll do is actually have female ones coming down out the bottom. So this is a simple board here. So I save that. Now there's two options here. I'm going to show how to do this on OSHpark, and I think that's actually the best thing for all of you. So this is a 1 square inch board at OSHpark. That's $5. So that's $5 in order to get 3 PCBs made and sent to you by USPS. So super cheap, not the fastest thing, but super cheap and easy. And I'm going to show you how to do that right now. Obviously, things could be a lot. You can go to any service you want to, and I think that's just a different set of videos where we're actually generating Gerbers. So this is just a way to simply get to this point. So let's go back and check this out. So what I'm going to do is go into here and check out the files that we've actually generated here. Right, we actually have not generated any Gerber files, but it actually doesn't matter. We're just going to go and upload this Kai Cad Pcb file, which should be fine. So we can go over to OSHpark, so OSHpark.com. I'm already logged in, so I'm going to say Get Started, and then I'm going to select the file from my computer. I'm going to go to my folder where it's in. I'm going to say Kai Cad Pcb, hit OK, and so I'm going to pause this while this thing processes. Okay, and it has processed. You can see a small preview here. So we're just going to call this Shine. I'm going to skip the description, continue here. It's going to show me all the different layers here. And you did see it was a little bit off in terms of the size. That's just because I drew it at the 1 inch mark, and I think it does it on the outside line or whatever it is. But so $5.05. But here's all the different layers here. We can see that this is a silkscreen layer. We can see the drills, the board bottom, which is the bottom copper, the top. This is the board bottom total, and then the top with everything on it. We can see there's board outline, bottom silk screen, bottom layer, which is the copper, and then that's the top copper. So basically all this stuff though looks good to me. So we're going to say we're good to go. This is approved, and now if I go and I can go and just order the board, and that's just going to pull in the payment, and so $5 and a couple days later, and it should get into the system. So hopefully that was a simple introduction. I know it probably went a little longer than you or I hoped, but there are a lot of steps to KiCad, and that's because it pretty much is a pro-level tool. For being open source, it's pretty pro-level, which is really surprising to a lot of people. I do know some people that are doing it, using it in a professional context. I use it in a professional context, and I think it's a really great platform for doing that. So this video hopefully got you to the point where you feel comfortable, you got a board finished. It's not a complicated board by any stretch of the imagination, but I think it's an interesting thing too, because it shows you going from a Raspberry Pi header out to a PCB, and you'll be able to control an LED from there. In the future, I'd like to go and do other small projects around that as well, using the Raspberry Pi header for turning on relays, talking to chips via I2C, stuff like that. So if you have any questions, there is a forum for contextual electronics specifically, so you can go and ask a question over there, and we will link it below. There will be other videos that are linked to the project site. So contextualelectronics.com is a service teaching people how to build electronics, and not just small PCB type stuff, but also how do you design with different components? How do you understand the theory behind it? How do you put all this stuff together? But I just wanted to make a introduction for people that are in software, have used Raspberry Pi, and are ready to kind of move to that next step. So that's what this was. Hopefully you agree with that. If you like this video, please do give it a like or a thumbs up down below, and please share with other people you think might be interested as well. All the other links will be down there. That's all for now. Thanks for watching, and thanks for being part of Contextual Electronics.